In this video, I want to talk about how to solve exponential equations. And exponential equations are equations where the variable is in the actual exponent. And there are two different types of exponential equations. The first case we're going to look at is a to the x equal to a to the y. So the main thing is the base of the exponent is the same on both sides of the equation. And if this is the case, we just set the exponents equal to each other. So let's look at some examples. Here we have 3 to the 2x minus 4 equal to 3 to the x plus 6. So we can see we have the same base on each side. So therefore, we just set the exponents equal. 2x minus 4 equal to x plus 6. And then we can solve. We'll start by getting all the variables on one side, so I'll subtract x from both sides. That gives me x minus 4 equal to 6. I'll then add 4 to both sides and get x equal to 10. So now I have my solution. My next example, 2 to the 3x plus 7 equal to 32. We can now see that we don't have the same base, but we can rewrite these to be in the same base. 37 is 2 to the 5th. So now we do have a 2 as the base on both sides. So we can just say 3x plus 7 is equal to 5. Subtract 7 from both sides. That gives me 3x equal to negative 2. And then dividing by 3 gives me my solution, x equal to negative 2/3. So we may have to do a little bit of extra work by rewriting one of the sides so that they both have the same base. Another example, 9 to the x minus 4 equal to 27. So here they're not of the same base currently, and I cannot write 27 as 9 to some power. However, I can still write them with the same base. 9 is 3 squared, so this is 3 squared to the x minus 4. And 27 is 3 cubed. When we raise a power to a power, we multiply. So this is 2x minus 8, since we need to distribute our exponents, is equal to 3 cubed. So now they both have the same base, and I can just set the exponents equal. 2x minus 8 is equal to 3. I add 8 to both sides to get 2x is equal to 11. Divide both sides by 2, and I get x is equal to 11 over 2. So I have my solution. So we can use this method if both sides of the equation either already have the same base or can be rewritten to have the same base, like this example here. However, what about this case, 3 to the x minus 4 equal to 5? I cannot write these as the same base like I could in my last example, so we need to use a different method. The first step is to actually take the natural log of both sides. The second step, we're actually going to use this property of exponents that say ln of a to the b power is equal to b ln a. So if we raise this to a power, we can just move it out front. And then finally, we solve the equation. So let's look at some examples of this. So let's go back to our example, 3 to the x minus 4 equal to 5. The first step says to take the natural log of both sides. So ln of 3 to the x minus 4 is equal to ln of 5. We then use the property that brings the exponent down front. We do need to make sure to put that in parentheses since it is the whole thing times ln of 3. So the wrong way that a lot of people write this is just x minus 4 ln 3 equal to ln 5. So in this case, I'm only multiplying the 4 by ln of 3, whereas I should be multiplying the entire exponent. So do make sure you watch for parentheses here. I can then divide both sides by ln of 3. The left-hand side is then x minus 4. If I do ln of 5 over ln of 3 in a calculator, I get approximately 1.46. We can then add 4 to both sides, and we get x is equal to 5.46. So we have an approximation of the solution. Next, 4 to the 3x minus 2 plus 1 equal to 12. In order Next, we have 4 to the 3x minus 2 plus 1 equal to 12. Before I take the natural log of both sides, let's set it up so that I just have an exponential equal to a number. So I'm going to subtract 1 from both sides. That gives me 4 to the 3x minus 2 equal to 11. And now I'll take the natural log. The natural log of 4 to the 3x minus 2 equal to the natural log of 11. We then use the property that says we can bring the exponent out front, making sure to leave it in parentheses. And then we can divide both sides by ln of 4. When we do, we get 3x minus 2 is equal to approximately 1.73. So I'm going to go ahead and move this up here to give me a little more room. We can then add 2 to both sides. That gives me 3x equal to 3.73. And then divide both sides by 3. When we do, we get approximately 1.24. So this would be the solution to this equation.